Alright, in this video we're going to do quiz 3 practice. My recommendation is before you watch this, you want to pick out some of the problems. So we're going to look at two different files. There's the quiz 3 example and quiz 3 fun. The example are problems that were created by the students, and fun are problems that were created by me. Some of them I'll type an answer, some of them I'll say just the basic idea. And yeah, we'll see. This could be a long video, but so my suggestion is you want to pick some of the problems from both files to try on your own right before you watch, because it's different. You have to practice trying it on your own. Maybe you're not going to have time to do them all, but pick every third problem or something like that and write down your answers before you watch the video. And I will go ahead and take some notes in a different file so you can keep that file pure. You can look at it and you won't have to worry about any spoilers. Okay, so let's see, why don't we start with the questions from the students. Alright, so the first type of question was some piece of code to run through, and the second type of question was any kind of short answer or fill in the blank. Alright, let's start with this one. So we have a loop that goes from 1 to 26 and increases by 2 whatever's in the array. So I'll put the answer here. Note this would be a runtime error potentially, because C bracket 26 is not okay, or rather C bracket 25. This loop goes from 0 to 26 and we only actually have 10 spots in there. But besides that, so that's one thing. Alright, besides that, this is increasing by 2 each of the characters. So J would turn into L, K would turn, they're in order here, J, K, L, M, N, O. So J turns into L, K turns into M, L turns into N, M turns into O, and then N turns into P, Q. So it would be something like that, but then, right. That is that one. All right, what is the difference between signed and unsigned? And I said specifically, what is the difference between int x and unsigned int y? The answer here would be that this one range is -2 to the, I'm putting the caret here for a power, I don't mean XOR. This is -2 to the 31 to 2 to the 31 minus 1. And this one, the range is from 0 to 2 to the 32 minus 1. Okay, that's signed and unsigned. All right, let's see this one. I shift left it by 1, it multiplies by 2, so that's 128. We're going to do some bit ORing. So in binary, this is 1 0 0 0 0 0 0 in binary, and then we're going to OR in 0x112, so that would be 0 0 0 1 0 0 1 0. There's a 0 here. Okay, so if we OR those together, then we have 1 0 0 1 0 0 1 0. Now we're going to shift right by 3, so that chops off these bits. So we'd have 1 0 0 1 0 in binary, which is, I think, 18. All right. What keyword identifies a loop that keeps track of a variable for you? That is not a good question. We'll skip it. All right, I equals 0, I less than 3, I plus plus. So we're just going through 3 times with I and doing things to num. Num is 1, 2, 3, 4, 5, 6. So the first time through, we're doing 1, 2, 3, 4, 5, 6 plus 1 shifted by I. When I is 0, you shift by 0, so that would be 1. So that's 1, 2, 3, 4, 5, 6, 7. Next time, we're going to do I is 1. So 1 shifted by 1 is 2. So that's going to be 1, 2, 3, 4, 5, 6, 9. And the last time, I is going to be 2. I shifted by 2, so that's 4. So this is 1, 2, 3, 4, 5, 7, 3, if I didn't make any mistakes. Skip that. Let's look at this one. A is zeros, and then we OR in AB. Now we're going to AND 0F. So then the result after this, the 0 and A part is 0. F and B is just going to be B. So right now it's 0x, 0b. The tilde is not. Is tilde not? Bitwise not. All right, so we're complementing all the bits. This would be, well, now it depends on, right, so this is really, so it really looks like this. Now, if we're going to flip all the bits, we would do 0x, and B is, let's see, B is 11. So let me put that over, let's see, we'll do it like this. 1, 0, 1, 1, that's B. So if we flip those bits, we have 0, 1, 0, 0, which is 4. Then if we shift by 2, we're going to have 0x. 2 of these bits are shifted over, so we'll have 3, FF, F, FF, F. And here we had the 4 was 0, 0, 0, 1, 0, 0. These 2 get chopped off, and we still have these 2 with 2 bits from that F. So this is what? C? Right, so that's 13, which is D, I guess. All right, so that would be what's printed here. And you'll have to try this to see that if that's how it actually works out. Struct, we'll skip that. Let's see, all right, x is 50. Then we do mod 3 plus 5. The mod 3 happens first. So we'd have 2 plus 5 is 7. Then we shift right by 1. 7 is 1, 1, 1, 1. So now x is 3. So that would be a 3. How many bytes does a long double take in memory when using GCC on CS? I believe this is 16. And you would print out size of long double. Or you declare a variable that's long double and do size of that. All right. Here is another one. So we have A, B, C, D, E, F. And the loop here, we start at 0 and we go as long as this is true. And this will be true as long as we haven't hit the null byte. So this I will go through each character here. So we'll just put here what we have. This is going to be weird. Let me just do the first one. So let's say what happens with the first time. We have c bracket 0 equals, so it's plus equals, so equals c bracket 0 plus c bracket 0. Okay, so all right, well, that's not so bad. So plus equals c bracket I and 1. So that is either going to be 1 or 0. So if this is even, it's going to be 0. If this is odd, if c bracket I as an integer is odd. So if we're looking at the first letter, we have A and 0x01. So we need to look at the actual integer value of A. Lowercase a is 97, which is odd. So 97 bitwise and of 1 is 1. So that's going to be plus equals 1, which puts a b in here. Okay, when we get to doing b, we would have c bracket 1 plus equals b plus 0x1. The code for b is 98, which is even. This and 1 is going to be 0, so b doesn't change. If we just continue the pattern, c is going to go up by 1, d is not, e is going to go up by 1, f is not. Alright, so that's a good question. That's fun. Alright, let's look at this one. Same kind of loop here. We're going to go through each letter in the string. And this gets kind of strange. So let's see. We're printing I, C bracket I, and 32. False or true. Okay, so let's just look at the first one. So the first time through, we're going to print C bracket 0, and then the character, so H. And then we have a %s. So we're either going to do false or true. That's this last parameter. And it's going to go depending on C bracket I and 32. So we have to look at the, what does this evaluate to? So let's look at it for H. I'll just put it over here. So H and 32. We have to look at the ASCII value for H. I'm going to write that as A plus something. I'll just leave it as something for now. Okay, so the ASCII value for capital A is 65, and it's plus something, whatever H is, whatever spot it is in the alphabet. But if we look at the binary value of whatever this is, it's not going to have a 1 bit in the position for 32. So if you remember, if we have some binary number here, so this would be the 0, or this would be the 1's bit, 2, 4, 8, 16, 32, 64, 128. Okay, so this third and 32, what that looks like is there is a 1 right there. That's what 32 looks like. And so the only way that we're going to get anything besides 0 out of that is if this number, the ASCII value for capital H, if that has a 1 in its binary representation. 65 is 1000001. So 64 and a 1. The only way we get up to 32 is if we go 31 higher than that. The H is not going to be that high. So this is going to be a 0. And the way this thing goes is if this is true, the question mark evaluates to the first item. If this is false, it evaluates to the second. So what we'll actually have here is true. Let's see. And that's this whole expression here. You evaluate this expression, the first thing. If it's true, then the value of the whole expression is the first item. If this expression here is false, then the value of the whole thing is true, the second part. So this is supposed to be, it's a shortcut for if C bracket I and 32, then false, else true, something like that. Okay, so that would be C bracket 0. Let's look at C bracket 1. So here we're printing, right, I is going to be 1. First we print this C bracket I, which is 1. We print the character, and then we have to evaluate this C bracket I and 32 again. So we have to look at the ASCII value for E. So ASCII value for A is something. E is some amount later. If we look at the binary value for 97, that is 0110 0001. So we have a 64, 32, and 1. That's the binary for 97. All right, we do have a 1 in the 32 place there in A. This would be for A. E is going to be some amount further, 5 or 6 or whatever it is. The only way that this 1 stops being there is if we get all these other things filled up. So we have to go up to 128. So if we get to 128, then this would turn back into a 0, and this would be a 1 up here. It's not going to be that big, so this 1 will be set. So now we'll print false. All right, and we're going to go through like that. For the lowercase letters, we're going to get a false. For the uppercase letters, we're going to get a true, unless we get up to, is this W up to 96? I don't think so. So we'll just go like that. All right, the next one. C equals A, so that is 97. Sorry. Yeah, 97. Now we're going to do plus equals 4, so that would be 101 plus x minus w. That's 1. W, x, y, z, so that's going to be 102. Okay, now we're going to subtract off 4 minus 1. So 4 minus 1 is 3. So we have 102 minus 4 minus 1. So that is now 98. Okay, we're subtracting off. So we have 98, and we're going to subtract off 97 minus 65, which is 32. So we're subtracting off 32. Now we're at 66. And we print 66 as a character, that is capital B, and as a number, it is 66. Okay, let's look at this one. So here we do the operations left to right with multiplication and division first. So 70 mod 8, that is 4. I'm just going to do the first one first, because these do get evaluated one at a time by the program. So now we do 4 times 2 is 8, plus 4 mod 3. Okay, so now we skip the plus and do the percent first, because that comes first with order of operations. That's a 1. And we still have the 8 plus. All right, now we finally do the plus, and there's a 9. Storage size and value of an unsigned char. All right, an unsigned char on CS with GCC is 1 byte, and the range is 0 to 255. Okay, we'll do this one. C now, all right. So C is going to be 99. If we shift C by, so we're going to do 99 plus 99 shifted by 2, which is the same as dividing by 4, which is easier to do here. So this is 99 plus divide by 4, round down is 24, so that's 123. All right, now we go I equals 1 to 4. We're going to do, all right, let's see what we got here. We're going to do plus plus C, so we increase already, and then we do OR 1. All right, so 124 is even. If we OR by 1, we get 125. All right, next time through, I is going to be 2. We do the plus plus first, and we OR it by 2. That's not going to change. 126 was even, so it had that that second bit set already. Now we're going to do again 126 plus plus, that's 127, or I is now 3, which is 127. And that's what was said there. Okay. That's 127 because this 127, the binary for that is 1111, 1111 without. This is the binary, and we already have 3 is 11. Just 11, right? And the rest of these are zeros. So if you OR those together, you still get 127. Skip past that. All right, let's see, we have a number that's in floating point. So we're going to print %.01f times. All right, so this is going to be maybe something like 10.00. I'd have to look it up. %.0LL, so the LF is long float. .0, let's look it up. Dot precision, okay, let's look at the precision. Number of digits to be written. Number of digits to be printed after the decimal point. All right, so that means we're going to just display 10 there. Okay, and then we have, this is going to be times %d, I is 0. And then we have the product I times number, which is 0. Second time through, number is still 10. And then we have times I is 1, so now it's going to be 10. And then that goes all the way up to number. So it eventually gets up to 10 times 10 equals 100. Okay, that's that loop. Now let's take a look at this one. We have k, 1 up to number. So now we're doing division. Okay, so we have %010LF number, so that's 10 divided by 1 equals, now this %2 is going to be 2 decimal places. We have number over k, 10 over 1 is 10. Second time through, we've got 2, that's going to be 5. Let's see, that's going to be 00, 5.00, the .2. Next time, 3 equals 3.33. 4 is 2.50, and so on. Okay, what is a switch statement? You could say what's it used for. You could say something about it takes an integer or a character and makes it easy to do different things depending on the value of the integer or character. Alright, we'll call that it for this one. We did the questions from the students. The next video we'll do the questions from me.